Welcome to all for today's class. In today's class, we are going to discuss about the pre-pregs in composite manufacturing. In this, we are going to have a new word called pre-pregs. In composite manufacturing, pre-pregs are one of the most critical and high-performance materials used for creating advanced composite parts. The term pre-preg is a short for pre-impregnated fiber. For pre-impregnated fiber, it meaning that the reinforcement fibers like a carbon fiber, glass fiber, aramid fiber, like that. They are already impregnated with a partially cured resin system. The resin is typically a thermoset polymer, such as epoxy, polyester, or phenolic, which provides the matrix that binds the fibers together after curing. Prepregs offer excellent consistency, strength, and surface finish, and are extensively used in aerospace, defense, motorsports, marine, and high-end industrial applications where performance and quality are non-negotiable. What are prepregs? Prepregs consist of reinforcement fibers. It is a continuous unidirectional fiber. Woven fabrics or non-woven mats, resin matrix, thermosetting or thermoplastic, which is partially cured. It's called a beta stage. The resin content or fiber orientation and curing behavior are tightly controlled using manufacturing, which allows designers and engineers to create parts with predictable and repeatable properties. Unlike traditional wet layup methods where resin is applied manually, prepregs eliminate variability by predefining the resin to fiber ratio and ensuring through impregnation under the factory condition. Next, we can go for the manufacturing process of the prepregs. What are the production of prepregs? It involves several controlled steps. One is fiber unwinding, in which the continuous fibers like carbon or glass fibers are unwound from reels are aligned. The next one is resin impregnation. The fibers pass through a resin bath or coated with resin via film lamination. In the case of thermoset prepregs, the resin is partially cured by passing through a heated oven or rollers. The next step is cooling and consolidation. The impregnated sheet is cooled to stabilize the resin. It is then laminated with a release paper or a carrier film on both sides. The next step is cutting and packaging. The prepreg is cut into rolls or sheets. It is stored in refrigeration, in which the range of temperature 0 to 5 degrees Celsius to slow further curing and preserve shelf life. And we should know the types of prepregs also. By fiber type, carbon fiber prepregs we are having, and glass fiber prepregs are having, aramid fiber prepregs are having. You know the importance of carbon fiber, glass fiber, aramid fiber. In the previous class itself, we have studied for carbon fiber, it has a high stiffness and a low weight, which is used in aerospace and motorsports. Glass fiber prepregs is economical and corrosion resistance. Aramid fiber prepregs are high impact and abrasion resistance. By resin type, we can have the types of prepregs or thermoset prepregs. It's the most common one. You can have epoxy, phenolic, polyester, vinyl ester, as well as thermoplastic prepregs are there. Here, instead of using high performance resins like PEEK, PPS, and PEI, we are using recyclable and more damage tolerant one, as well as it requires a higher processing temperature also. Then we should move on to the applications of the prepregs. As said earlier, it is used in aerospace and application defense also, like fuselage components, wing spars, flarings, satellite and UAV pods, radomes and rotor blades. Here the prepregs are very much useful. In motorsports and automotive, monocoque chassis, as well as body panels, suspension parts, brake decks and aerodynamic surfaces. And in marine applications, hulls and decks for high performance boards, lightweight panels for reinforcements. Then electrical and electronics, here printed circuit boards as well as insulation components. And construction point of view, bridge reinforcements, blast resistant panels. Here the prepregs are very important. Then we should know the prepregs advantages. Fiber volume ratio, that means fiber volume fraction is high, up to 65% fiber content, which is resulting superior strength and stiffness. And we have the consistent quality. Then surface finish improvement is higher, and wastage due to this pre-pigment are reduced, as well as the properties are tailor based. That means specific fiber orientation, resin systems, and the hybrid layers for custom performance are very much useful here. And handling is very clean. That means no mixing or no dripping of resins. Finally, the limitations of prepregs are: one is cost, second one is the storage requirements, third one is the processing needs, and labor equipment. Finally, the shape limitations. In shape limitations, layer of complex 3D shapes can be time consuming and may cause fiber distortion. As well as the curing and consolidation, here we have curing methods also, like autoclave method, oven curing plus a vacuum bag, out of autoclave. Then these kind of things we have been here to find out the prepregs importance. So that's all for today's class about the prepregs in composite manufacturing. We will see in the next class with a different topic. Thank you, Andal.